Welcome to Math with Mr. P. Today we're doing Chapter 1, Lesson 4. This is 7th grade math. Today we're going to be talking about proportional and non-proportional relationships. This one may be a quick one because it's just introducing what are proportional, non-proportional, and equivalent ratios. So let's look at our notes. A proportional ratio, or proportional, is where there is a constant ratio, unit rate, or rate. So for example, for every 1 hour this person works, they get $18. If they work 2 hours, we double 18 and it's 36. 3 hours, we triple 18, it's 54. 4 hours, we quadruple it. And then 5 hours would be 18 times 5, which would be $90. So there is a relationship there where every time the unit rate goes up, the other outcome, so every time they work 1 hour, they're making $18. So 18 more gets added each time. Here, 1 more gets added each time. So there is a constant proportional relationship there. Equivalent ratios. So one could even say that 18 over 1 and 72 over 4 are equivalent. They are because if we simplify them, all of these right here, 36 over 2, 54 over 3, 72 over 4, 90 over 5, which was what we said 18 hours times, or 18 times 5 is 90. All of these right here are equivalent ratios to 18 over 1. They are all equal to 18 over 1 when we simplify them. It's like using that example of equivalent fractions, for example. Start with a blank canvas. So 1/2 can be written as 2/4, be written as 3/6, be written as 4/8, 5/10, 50 over 100, 25 over 50, and so on. All of these are all going to relate back to 1/2 because they are all 1/2 in some form or another. If I divide these both by 25, divide these both by 50, divide these both by 4, divide these both by 5, divide these both by 3, and divide these both by 2, they will all end up becoming 1/2 when all is said and done. Same relationship here. It's 18 over 1. If I were to divide these both by 2, it'd become 18 over 1. Divide these both by 3, it becomes 18 over 1. So these are equivalent ratios. Equivalent ratios and proportional, not the same, but very closely related. Remember, proportional, we're looking at these all in a relation, that they are all jumping up at a constant rate. They may not be related, they may not be equivalent to each other, but they are all going up at a constant rate. Equivalent ratios, they are ratios that all equal each other. And 18 over 1, 36 over 2, and 54 over 3 are all the exact same ratio. They're all 18 over 1. So they are equivalent. And then non-proportional. It's when a ratio or unit rate is not constant or not proportional. So this one says that every 1 ticket costs $10. So if this were a constant rate here, that means 2 tickets would cost $20. But in this case, it doesn't. It costs $17. So there's a discount there if you buy more than 1 ticket. So therefore, this did not carry over. 3 tickets is $24, where if this were constant, 3 tickets would cost $30. 4 tickets should cost $40 if this was constant. This is not constant. So if we look here at our examples, if we pay $17 for 2 tickets, that means each ticket is $8.50 if we pay for 2 tickets. Versus over here, we had $1 cost 1 ticket costs $10. If we buy 3 tickets for $24, each ticket is $8. And if we buy 4 tickets for $31, each ticket is $7.75. So in this case, there is a sliding scale here where the more tickets you buy, the less money you spend, but there's also not a constant or proportional relationship between each ratio. Therefore, none of these are equivalent, and none of them have a relationship to each other that is constant, meaning the numbers don't just keep changing up at a constant rate. Each of them changes at a different rate. So, going to the textbook. So again, make sure proportional, non-proportional, and equivalent ratios are in your notes. Again, this is going to be kind of a quick lesson. Let's go to an example. We used that example already. So let's do this got it really quick. So we're going to do this problem to find out. At Lakeview Middle School, there are 2 homeroom teachers assigned to every 48 students. Is the number of students at this school proportional to the number of teachers? Explain your reasoning. So, again, at Lakeview Middle School, there are 2 homeroom teachers assigned to every 48 students. Is the number of students at this school proportional to the number of teachers? Explain your reasoning. Now, we would need to have a little bit more information here, I think. But let's see. So, we'll go ahead and write this down. This is saying for every 48 students, there are 2 teachers assigned. So there are 2 homeroom teachers assigned to every 48 students. Is this number of students at this school proportional to the number of teachers? Explain your reasoning. All right, and we're back. Sorry, I had to pause for a second there. So this one's a weird question, but basically what is happening here is it's saying that there are 2 homeroom teachers assigned for every 48 students. So we wrote our ratio like this. Now, basically, if I divide these by 2, what it's saying is that for every 24 students, there is 1 homeroom teacher. So it's asking us if this is proportional to the number of each teachers. Explain your reasoning. Now, without any other information, we know that this is an even number, 48. And 2 is another even number since there are 2 homeroom teachers. So yes, it is proportional. There's for every 24 students, they should have 1 homeroom teacher. So 1 teacher would teach 24 students. That would be great, but that's not how it works here. So yes, it is proportional. Now, say there were 49 students with 2 homeroom teachers, it would not be proportional because one would end up with 24 students while the other one would end up with 25 students, and that is not proportional. So because 48 could be divided by 2 in this case and split up into 2 classes of 24, this is proportional. Let's do another example. Uptown Tickets charges $7 per basketball game plus a $3 processing fee per order. Is the cost of an order proportional to the number of tickets ordered? Explain. So again, 1 ticket ordered would cost $7 plus $3, which would be $10. 2 tickets ordered would be 7 times 2, which is 14, plus $3, which is $17. 3 tickets ordered would be 3 times 7, which is 21, plus the $3 charge, which is 24. So if you notice, these are not equivalent ratios. Therefore, 1 ticket would cost us $10. 2 tickets would cost us $8.50 per ticket because of the $3 surcharge. $24 for 3 tickets means it would be paying $8 per ticket. $31 for 4 tickets means we'd be paying $7.75 per ticket, which is what we did in our notes. Since the ratios of these 2 quantities are not the same, the cost of an order is not proportional to the number of tickets ordered. Because remember, they are not charging you $3 processing fee per ticket, it's per order. So it doesn't matter if you order 1 ticket or 5 tickets, 10 tickets, 20 tickets, you're still going to be charged a $3 charge per order. And it doesn't matter how big your order is. So no, this would not be proportional. Now, if they said they charge you $7 per ticket plus $3 processing fee per ticket, then yes, each ticket would be $10, and you'd see this be 10 over 1, 20 over 2, 30 over 3, 40 over 4, 50 over 5, and it would be a constant relationship. But because it's a $3 processing fee per order, and the number of tickets you order is different, it is not proportional. You can use the recipe shown to make a fruit punch. Is the amount of sugar used proportional to the amount of mix used? Explain. Find the amount of sugar and mix needed for every number of batches. Make a table to help you solve. So it's saying that for each half cup of sugar, you're going to use 1 envelope of mix. Over here, since we are using 2 envelopes of mix, you will double the 1/2, so it's 1. 3 cups, triple 1/2, so it's 1 1/2. 4 envelopes of mix, 2 cups, which is quadruple this. So yes, there is a relationship. Each one of these is going up by 1, while each one of these is going up by 1/2. Therefore, each envelope of mix will use a 1/2 cup of sugar each time. So all the ratios are equal. They are all equivalent ratios. There is a relationship between each of the ratios, and it is constant. Therefore, this is a proportional. This whole table is proportional. All right, and let's do B. And then I think that's a video. At the beginning of the year, Isabel had $120 in the bank. Each week she deposits another $20. Is her account balance proportional to the number of weeks of deposits? Use the table below and explain your reasoning. So, we're going to reread this question again. At the beginning of the year, Isabel had $120 in the bank. Each week, she deposits another $20. So, the first week here, she already had $120. She's going to add $20 each week, which means the first week she had $140. During the second week, she's going to add another $20, which means she's going to have $160. And the third week, she'll have $180. Now, are all of these proportional? So, again, I'm going to go ahead and erase this, and we are going to pull up the definition again for proportional. Where there is a constant ratio, unit rate, or rate. So, is there a constant there? Now remember, with our last example here with the tickets, there was not a constant. Well, let's see. It's saying they're not proportional. So let's see. 10 plus. So there is, so this one's a kind of confusing thing, but let's see. This is saying no. So ratios of two quantities are not the same. The cost is not proportional. Okay, so remember, they're not looking at the relationship, because yes, each one of these is raised by $7, so there is a constant, quote unquote, but they're not proportional, meaning they're not equal, which is where the definition up here gets a little confusing, because it's saying proportional is where there's a constant ratio, unit rate, or rate. So be aware that proportional means that they are all equivalent. Proportional and equivalent ratios are basically the same thing. It's not just a change being seen in each one. So when it comes down to this example here that we have used with Isabel depositing money, are these all consistent? There is a consistency here, but the fact that she started with $140 or $120, I should say, in her bank account messed this up. If she started at 0 and she's adding $20, $20, this would be proportional, because 1 to 20, 2 to 40, 3 to 60, these would all be equivalent and it would be proportional. But the fact that she already had 120 in her bank, these are all offset. So, for example, the ratio here is 1 to 140. For this, we would have to double 140 for this to be proportional. So, if I take 160 and divide it by 2, this would actually become 1 to 80, which is not 1 to 140. So, they are not proportional. And then on the flip side, the 180 divided by 3 would give me 1 over 60. So, even though her bank account is increasing $20 each week, these are not proportional. They are not equivalent ratios. Again, if she had started at $0, yes, because every week she's coming up by $20, and $20 is being added to each account. But because she started with the 120, they are not equivalent. And therefore, it is not proportional. So, your homework will be dealing with these tables and telling me if they're proportional or not proportional. So, for exercise number 1, we'll do number 1 together. For exercise number 1 through 3, write the ratio in the table to show the relationship between each values. So in this case, they just want us to write the relationship with the ratio. So $1, 1 hour, $15 earned. It would be 1/15. To $30, it'd be 3/20. Sorry, we should have done it the other way around. $15 per hour. This would be $30 for 2 hours, or it would still be 15. It's still $15 an hour. 45 over 3, $15 an hour. 60 over 4, $15 an hour. So I know it's very tempting just to copy this down and do this as your homework. Please don't. You're going to need to understand these because for sure, this is going to be a quiz. So please do not get in the habit of just copying this down. You're going to have to show some work. You're going to have to understand how these work because this will be a quiz. So as always, any questions, comments, concerns, you guys know where to send those. Otherwise, I will see you in class for the live teaching. As always, this is Mr. P, and I'll see you guys on the next one.